Hello, so this is a revision video for AP Chemistry 7.7, calculating equilibrium concentrations. You may be asked to calculate the concentration of a species in an equilibrium mixture by using the equilibrium constant, Kc or Kp, and some given data. For example, calculate the equilibrium concentration of H2 for the following reaction. H2 plus I2 goes to form 2Hi, with a Kc value of 50 at 298 Kelvin. Now, if we assume that the concentration of Hi was 0 at the start, so we just reacted hydrogen and iodine together, the initial concentration of Hi will be 0. However, its change will be positive 0.8 molar. Because we know equilibrium, its concentration is 0.8 molar. Equally, the I2 has an equilibrium concentration of 0.1 molar. Well, if Hi increased by 0.8 molar, then the concentration of I2 must have decreased by 0.4 molar, because the ratio of I2 to Hi is 1 to 2. So if the concentration of Hi increases by 0.8, the concentration of I2 must decrease by 0.4. This means the initial concentration of H2 will have decreased by 0.4 molar as well, because the ratio of H2 to I2 is 1 to 1. Now we have equilibrium concentrations in our table. Equilibrium concentration of Hi is 0.8, equilibrium concentration of I2 is 0.1, and equilibrium concentration of H2 is X minus 0.4 molar. Because whatever the starting concentration was, it decreased by 0.4. Now we just need to substitute these values into our Kc expression to find the unknown X. So the expression will be Kc equals concentration of Hi squared divided by concentration of H2 times concentration of I2. We're told the Kc value is 50, so 50 equals the concentration of Hi, 0.8 squared, divided by the concentration of H2, X minus 0.4, times the concentration of I2, 0.1. With some rearranging, this will give us 0.1 times X minus 0.4 equals 0.0128. This can then be simplified down further to X minus 0.4 equals 0.128. So with some further rearranging, X equals 0.528. Now remember, the question was asking us for the equilibrium concentration of H2, which we said was X minus 0.4. So 0.528 minus 0.4 gives 0.128 molar. That would be the concentration of H2 at equilibrium. Now, if a K value for Kc or Kp is very small, then that means very little product is present at equilibrium. Because of this, we can assume the reactant's equilibrium concentration is approximately its initial value. In other words, the concentration of reactant has changed so little that mathematically we don't really need to worry about it.